With triangles and other shapes, they may use a word called similar often. And similar means that two shapes are scaled versus congruent, which congruent means that two things are copies. Similar, think scaled. Congruent, think copies. So here's what I mean by that. Let's say we have two triangles, triangle 1, triangle 2. If they are congruent, it means that all three angles are going to be the same. So this would be a 90-degree angle. That might be a 90-degree angle. Let's say this is triangle ABC and this is triangle DEF. If these two are said to be congruent, then it means that these angles are the same. So if this is 35, then this is going to be 55, but A is congruent to D and A corresponds to D. D is 35 and F would be 55. They would also use maybe a word that is corresponding, which means that they are connected or linked. So A corresponds to D, for example. A corresponds to D, B corresponds to E, and angle C corresponds to angle F. And if they are congruent, then if AB is 1, then DE is 1. If BC is 3, then EF is 3. And if AC is the square root of 10, then DF is the square root of 10, because they are copies of one another. Now let's go ahead and think about if they are similar. In this case, the angles are still the same. Corresponding angles of similar triangles are still the same, but triangle DEF may be twice as big. Maybe there's a scale factor on DEF, and DEF is twice as big. Now in this case, all the ratios would be the same. So let's say this is 3, 4, and 5. If this was 6 and it corresponds to the 3, then that means that BC, since it corresponds to EF, must be 8, and it means that AC, since it corresponds to DF, must be 10. And I have a scale factor, once again, of 2. So it's times 2. Sides times 2. My angles are going to be the same, but my lengths may specifically be different. Now, even though that's the case, when it comes down to my trig ratios, my SO, CA, TOA, they are the same. So let's think of the sine of A and we'll compare it to the sine of D, corresponding angles. Sine of A is going to be opposite, which is 4 over 5. Now for the sine of D, it's going to be 8 over 10, but that simplifies down to 4 over 5 when I divide both the top and the bottom by 2. So as you can see, the corresponding angles that are similar have the same trig ratios, even though the lengths may be different.